Today's episode is sponsored by the new Refrigeration differential pressure monitor from Westermeyer Industries. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace the filter? Wait too long to service the filter, and you could end up with nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The new Refrigeration RDP-01 differential pressure monitor is available now with Westermeyer Industries. To find out more, email sales@westermeyerind.com. Once again, that's sales@westermeyerind.com. Look for the new pressure differential monitor, available now.
Hi guys, welcome to the Advanced Refrigeration podcast. I'm your host, Kevin Compass. I wanted to take a quick minute to talk about one of our sponsors that make this podcast possible, and that's Parker Sporlan and the Catch-All Filter Dryer. Do you know what can reduce system efficiencies and reliability within your refrigeration system? If you answered contamination, you are correct. Sporlan Catch-All dryers have been around since 1947 and have been perfected over the years to capture water, acid, solids, debris, including sludges and varnishes. For best practices, change the Catch-All filter dryer if any of the following occurs. Initial system install, when a system is open for service or repair, when excessive pressure drop of 5 psi across the filter dryer, when the See All sight glass indicates water is present, when doing a T1-1 acid test kit says there's acid present, during a compressor burnout cleanup, and following a successful burnout cleanup. To find out more information, by downloading Bulletin 40-10 from Sporlan.com with all the Catch-All filter dryer information. Thanks, guys. Enjoy the episode.
Good evening, everybody, and welcome to Advanced Refrigeration Podcast. We're here with your host, Brett Wetzel, Kevin Compass, and we have a special guest tonight from Motion Industries, Matt Asbill. How you doing tonight, Matt?
I'm doing pretty good. Thank you for having me.
Absolutely. Kevin, I have to ask, how's your week going?
Horrible. Absolutely horrible.
We were talking off air, and Kevin's had a real rough couple of weeks. You've been traveling out of town, right?
Yeah, I'm only like in 2 hours from the house. I mean, I'm still within the state of Indiana, but yeah, I'm on a job site where somebody tried to cut 45 days off of the job, and yeah, we are paying for it. We are paying for it indeed on the startup end.
Yeah. So if anyone knows, I've been staying at home here late for the past couple because my wife had back surgery, so I'm playing Mr. Mom and taking care of my wife, and I'm exhausted. Matt, how's your week going, man?
Not too bad. I got notification from a customer today. They lost an entire 25 horsepower VFD panel for the second time. The first time, they don't have any idea where it went. That was about 3 or 4 months ago. And then today they called me and said that they had an asset recovery truck come pick up some stuff. And so it's gone off to a warehouse. They don't know what warehouse. And so they're going to have to order the third VFD panel to make up for it.
Wow. Well, tonight, guys, we're going to be talking about, some advanced VFD stuff. I know, Kevin and I have talked about VFDs in the past, but, we're going to talk to a guy that, when I talk to, he makes me feel really dumb. So we're going to get into it. Before we do get started, I do want to say hi to Shank. He just went into the hospital. I just want to say hi to him, make sure he's doing all right. But so let's get started. Matt, tell everybody about yourself. How long you've been in motion? How long you've been in the industry?
I've been working for Motion Industries right at 27 years. Before that, I worked for the government, aerospace and government down in Huntsville, Alabama. And then we created a HVAC department out of our Kansas City, Missouri branch. And that department has been running for about 15 years now.
And you started that department, yeah?
I did. We had a large customer come to us. Funny story. What happened was I live out in the country, and so we had a hayride for our church. And there was a local farmer that donated his truck and his trailer, filled it full of hay. We were out on the hayride, and I asked the guy, I go, "What do you do for a living?" He goes, "I work for Walmart." And I go, "Well, maybe he's just a greeter or works in the outdoor or sporting department." And it turned out he was an HVAC manager for Walmart. He was a regional manager, and he said, "What do you do?" I said, "I work for Motion Industries. I do AC, DC drives, motors, controls." And he said, "We're just now getting started in AC drives, and we're having problems and issues." And that day started my life with HVAC stores, WalMarts, refrigeration, things like that. And it's just snowballed ever since.
So if anyone's never had the pleasure of speaking with Matt, he works a lot with Walmart and Sam's Club, and helps with the troubleshooting and technical support for all the drives that they basically use, predominantly Commander SK, NIDEC, and Danfoss and ABB. Yeah.
Yes. Control Techniques was owned by Emerson, and then Emerson Control Techniques, which is what we still call them by that name, they were bought out by NIDEC. And so the Commander SK was around for a long, long time. And that product line was obsolete about 5 years ago, but they still have thousands and thousands of out there, not just at Walmart stores, but the Aldis, the Sprouts, all over the place. And that particular VFD was replaced by the new generation of M400. And so we do the Emerson, the old Emerson, the new Emerson, ABB, the Danfoss. I work with Schneider's and Allen Bradley. A lot of those systems are obsolete. And so we have replacement kits, if you will, for the Schneiders and the ABB, or I'm sorry, the Allen Bradley.
Awesome. Yeah. So, if anyone's not familiar, predominantly Walmart and Sam's Club does TD control, which I know we've talked about a whole bunch of times, as far as, some of the other podcasts we've done. Some of the drives that are out there, you have to get programmed from Motion Industries. Is that correct, Matt?
It is. The Commander SK had what was called a logic stick that was stuck into the front of it. Some people just call it a flash drive. And that logic stick, each one of them had the memory capacity to put the PT chart for one refrigerant on one logic stick. So if you had a store or an application that you knew had R22, you would get R22 sticks. If you ever had an upgrade to 422, you would have to pull that stick out and replace it with a new stick. Now the new M400s, what we do is we put a program into them that has all the refrigerants inside it. So all you have to do is go up and select what refrigerant you're using, and that will replace all of the Commander SKs and all of the logic sticks that were out there. Now, there are some applications that have going back to the logic sticks and the programs, those are what we call smart VFDs. The VFD itself takes in typically like a pressure transducer and a temperature probe, and that's where it does its TD calculations, and it controls the speed of the motors all by itself. There is also a dumb VFD And that can be Danfoss or that can be Emerson M400. And the EMS controller does all the calculations. It has the discharge pressure or the drop leg pressure. It has the temperature, and it sends out an analog voltage to the VFD, and the VFD's in dumb mode, and it just does what it's told. Now, sometimes that signal is 0 to 10 volts, and sometimes that signal is 10 to 0 volts.
No, man, I got a question. So the M400 specifically, so that particular drive, you can't just order an M400 from Emerson and just plop it in as a replacement, correct? I mean, doesn't it have to have the PT stuff enabled in there?
That is correct. We stock them on our shelf because you can't just order one from the factory or off the shelf. We put in a refrigerant program, and it's embedded in the source code of the VFD itself. So when you take it out of the box, it has a different parameter set than default. And so, it will come up and say, what refrigerant are you running? What pressure transducer do you have? What ambient temperature probe do you have? And all those parameters are not in the factory box. And so, yes, you have to get that with the program already embedded in it. Emerson Control Techniques, Nidec, they do not put the program in there. We do.
Yeah, Kev, I had an instance where someone ordered a drop. I had specifically called Motion. I called Matt and got a quote from Motion. Basically gave them the part number of everything that needed to be happening, and then for some odd reason, someone else went to go up install the drive. And I called Matt. I was like, man, I'm pretty sure, I don't know where we got it from, but the program's not in there. And basically that's what ended up having to happen. We had to actually send the drive, out to Motion, to get programmed because they goofed. And I think ABB is like that as well, right? I think the only drive that you can actually, program fully, right, is the Danfoss one. So you can take a regular standard, Danfoss VLT and basically, take the fascia off and copy the program and put that over. And that's one of the only drives that you guys deal with, for or Walmart and Sam's Club that does that, right?
I thought the ABBs you could.
It is, as long as the ABB drive will come with a program embedded in the keypad. So if you bought an ABB drive from XYZ company, it would not work without the custom keypad that had the custom refrigerant program embedded in it.
Okay.
And the Danfoss would require the COM module. I think it's the MCP module that would allow you to do what you're saying.
Oh, it's a separate. Where's that installed on the drive?
It's underneath the keypad. It's a kind of like a motherboard attachment from the factory.
Oh, okay. All right.
Are you talking about where the terminals like 54 and is it 52 or 53 mount? Is that what you're talking about, Matt?
Yes.
Oh, okay. Yep. I know what you're talking about now. Matt, it was something I wanted to go over like a lot. Me and Brett went over a little bit. The importance of like shaft grounding rings.
Yes. Let me get back over here. So when you put motors on a VFD, strange things start to happen either on large motors or on multiple motors applications. So when you look at a refrigerant application, you have a lot of small motors. But what you do is you add up the lead length to each one of them. So if you had a 10 fan condenser and the VFD was mounted inside the rack house, you're looking at 15 feet per motor, 150 feet now, and then 20 feet from the condenser control panel down to the VFD. So you're looking at 150 to 200 feet of cable. And that's when bad things start to happen over like 75 to 100 feet. Depending on the VFD, strange things will happen to the motors. And put out harmonics and what we call corona. These voltages will go through the motor, and they're trying to find a way to get out. And typically, they will go through the drive-in bearing in order to get to a ground. So if you put a shaft grounding ring on it, then that will give them a low resistance path to ground and protect the front end bearing from what they call fluting. Think of it as little tiny lightning strikes. So every time the balls go round and round and they're building up this high voltage, they'll spark and it'll etch a small chunk of the race out. And so over time, that will destroy the race of the bearing. And that's when you can walk up to a condenser and you can hear the motors roaring, because roar, 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 or you can take a shaft and you can physically move it around. Typically, that's caused by the effects of the VFD going through the bearings of the motor. So we provide, most people have gone to the shaft grounding rings from the factory. You can also add them in the field. What we look for is, since this problem is also based on lead length out to the motors. If you had a 10-fan condenser, for example, not 100% of the time, but to a large extent, I would expect the motors further away to die first. Number 10, 9, 8, and 7. The others will die randomly, but the VFD is going to be harder on the motors that are further away from the VFD itself. And the shaft grounding rings are one type of insurance to try to prevent that specific type of arcing in the bearings, to prevent early failures on those. And I could go on and on about shaft grounding rings and what's going on, but that is one very specific type of failure in the condenser motors that shaft grounding rings do protect against.
Matt, do you guys recommend a specific, like obviously a horse and a half motor that already has them put in there? I know they, on a lot of those projects, they end up putting US motors, Verispeed motors in, is what I see. But like, do you guys recommend like a particular motor? I mean, because it seems like if you throw some off the wall like junk motor in there, without shaft grounding rings, they last like a year and that's it.
Yeah, we use U.S. motors. So what we did was we went to U.S. Motors 15 years ago, and we looked at all the motors that we came across in the condenser world, half horsepower, 3/4, 1 horse and a half typically. And so we went to U.S. Motors and we started designing motors. Our first round of motors, 12 to 15 years ago, did not have the shaft grounding rings in them, and they worked very well. But as time went on and we learned, we started putting the shaft grounding rings. So we have a proprietary motor that we designed with the help of U.S. Motors, and it has the shaft grounding rings already in it. It's 460 volt only, so it only has 3 wires that come out of it. It has what's called carding between phases. If you look at the phases inside a motor, then the electrical sparks, if you will, are going to try to go from phase to phase, and that's where you get a lot of shorts. And so we took an insulative, like a cardboard or a phenolic, and we put it in between the 3 phases, and that enhances the protection to fight against the phase-to-phase shorts. So what U.S. Motors did, kind of on the side, they saw that there was a huge market for HVAC motors for these applications. And so they took our designs for our motors and they made what's called the Very Tough motors. And the Very Tough motors come with or without the shaft grounding rings. And those motors are, very extremely durable. They're inverter duty. They pass all the NEMA, NEMA qualifications for inverter duty motors. You can get them without shaft grounding rings or with shaft grounding rings. And we call that an A motor. And we call our motor A plus motor because it's got a few more features in it that they didn't put in the Very Tough motor line. So to answer your question, U.S. Motors does have the product line that is called the Very Tough, and for condenser applications, that is a very robust and heavy-duty motor. There are also a few others, like A.O. Smith has a Juggernaut. What they do is they put conductive grease inside the bearings to try to suck up those voltages and get them to ground. But Regal Beloit has bought A.O. Smith, Marathon, a lot of these motor brands, and they also have inverter duty condenser motors now that have the shaft grinding rings on them as well. We've had a lot of luck with some of the Regal Beloit inverter duty condenser motors, but primarily over the years we've used the U.S. Motors Very Tough line and to great success.
Yeah. So if guys want to buy your guys' motors, they have to go through Motion Industry to get them, or can that be something that can be bought from like the motor supply house?
You kind of have to know. So there's a couple of answers to that question. So the Very Tough condenser motor line is available through any U.S. Motors motor distributor nationwide. And so, if you knew what you wanted, you could get a Very Tough motor from XYZ company in California or South Carolina, wherever you're at. Now, we have a little bit better motor than that. They have special part numbers. And as a matter of fact, the funny story, since we designed these motors with U.S. Motors, they came back to us and said, you've got to come up with your own part numbers for these motors because we're going to make them proprietary to Motion Industries. And so I took the initials of my 3 kids. I took the initials of a friend of mine, the operations manager in Kansas City, Missouri. And so, for example, one of the motors is SWA010905. Well, that's Sawyer William Asbill, my nephew. He's born January 9th. So I used, unbeknownst to anybody, I used some birth dates to assign part numbers to some of the motor lines that were proprietary to us. But since we're also it's called like a Gold Star premium distributor for U.S. Motors. Motion Industries has 500 branches nationwide, and our parent company is Genuine Parts, and our sister company is Napa Auto Parts. So they're considered the automotive division. We're considered the industrial division. Well, with 500 branches, we buy a lot of motors from U.S. Motors, and we buy a lot of their HVAC products through our Kansas City branch. And so they made us a premium HVAC distributor for their components and motors and whatnot. So anybody can go into any U.S. Motors distributor nationwide and buy Very Tough motors, but they can also get them from us. It's probably less money. It all depends on the distributor that they're talking to. But as a general rule, the Very Tough motors is a certain product line from U.S. Motors, and it's available through their distribution networks nationwide.
Right. That brings me to 2 questions. Oh, sorry.
I know I rambled.
I would love to get the.
I know I rambled around, Matt.
I mean, those Veritough motors are great. I mean, they hardly fail compared to the Juggernauts and other stuff. But I mean, if you got a better version that already has the shaft grounding rings on them, I mean, I would love to get those part numbers, because the ones that go into the Walmarts and Sam's and they do the retrofits, I mean, some of those go 3-4 years without issues. I mean, some of them are older than that without issues, as long as they haven't had a sprinkler on them.
Yes.
I mean, yeah, which I don't know. It seems to be a problem here lately. I mean, I would love to get those part numbers because, I mean, those are great motors.
Yes, and I can give you the brochure and the part numbers for both the Very Tough as well as our motor line. But what I will say is, even though that's a great product line, and these are really good, very durable motors, when I give my classes to stores and contractors nationwide, I'm very, very careful that I don't say, these motors, if you buy these motors and you buy these motors from us, they'll last forever, because that's not the case. There's a lot of things that go on when you buy a motor from anybody for a certain application or a certain condition. For example, we sold some of our motors to a store, and they failed and they failed and they failed. And they said, "Man, your motors suck, and we want a refund, and we're going to go somewhere else." So I said, I will. It was only 5 hours away. So I said, "I'll drive up there and we'll figure out what the problem is." And so when I got there, when I drove up, I could see the racks were outside on the ground, and when you looked up underneath the coils, it looked like a sheet of cardboard. All the coils were plugged, like 90%. There wasn't any air going through the motors, and all the labels were black because they burned up because there was no airflow at all. So you have to be careful when you look at motor failures on a condenser, or any application for that matter, anything industrial, HVAC. You have to be careful not to be blindsided by what you think the problem is, and you just go down that path, because there's, like in the HVAC world, it could be your choice of motors. It could be the coils are completely plugged up. It could be as little as the fan blade placement. When we give part of our school, part of our training is on fan blades. Now, I'm not a fan blade expert, but when you look at a fan blade on a condenser, typically it will have rivets, and you'll be able to tell the center line of the blade, where the hub is. And that center line of that hub should be pretty close to the center of the metal. Usually there's a 1 inch wide metal lip where the venturi is, that the motor is placed in. And we have seen where the motors were mounted wrong, where they were mounted in the wrong bolt hole pattern, or the installer took the fan blade and mashed them all the way down, or he pushed them all the way up because the motor had like a 6 inch shaft on it. And if they mount the very first fan blade wrong, they're going to mount them all wrong, because they'll use that one as a pattern. And if you get that fan blade too low or too high, you greatly decrease the airflow in that particular venturi, and you greatly reduce the ability of the motor to cool itself. And you'll, every time that motor heats up, you shorten the life by 50%. And so if you heat it up and it's burning up and it's a 100-degree day and the fan blades are in the wrong place, you just cut the life down by 50%. So instead of 7, 8 years, now it's 4. You let that go all summer, and then that motor may last you less than a year, maybe 6 months, maybe 3 months, because you flat out just burned it up beyond the limits of the insulation inside the motor. And most of the HVAC motors, if you'll notice, rely on the airstream of the fan blade that is turning to get rid of its heat. And so, another factor is, not many people realize that when you, on a VFD, if you give it a run command, but you give it a 0 speed command, and the VFD is enabled, and it says frequency 0 hertz or run 0 hertz, you have to keep in mind that it is putting out what we call magnetizing current to the motors. So if the motor is 2.5 amps, there's going to be a half to 1 amp of current going out to the motors, even though they're not turning. And that magnetizing current at 0 speed or less than 5, 6 hertz will slowly cook the motor inside out, because there's no air movement and there's no way for it to get rid of its heat. So early fall or spring, when the temperatures are just right and the speeds go down, you have to be really, really careful about having a 0 speed control algorithm, because if you're not turning the motors, and the factory will say 6 hertz. Usually the inverter duty motors on a variable torque application will have a 10-to-1 speed range, which means 60 hertz down to 6 hertz. So if you're turning the fan blades less than 6 hertz, you have not much airflow, and you're not cooling the motor, and the motor will slowly burn itself up. And so you have to be careful that If the pressure goes down, a lot of times it will revert over to half the motors, like in split mode. But there are various times where I've gone up. You can hear the motors humming, and they might be turning or they might not be turning. And what that is you can hear the motors cooking themselves to death because they're not moving. And so the inverter duty motors, the very tough motors, will last longer because they have a higher grade of insulation in them. But they're still going to cook to death. They're just going to last longer than just a common old everyday general purpose motor, because a general purpose motor may have class B insulation. The inverter duty motors will have class F as in Frank or H as in Henry, and so you're just delaying the fact.
So why do some customers, put in? I mean, I was told price when I asked this question to a customer, and some customers, they'll use class B, and I've always been taught class F or above. You know what I mean? As far as insulation, basically, if the motor, the idea behind it, from my understanding, since the motor is able to move slower, you're obviously not moving in as much air, right? So if you're not moving enough air, you're not cooling down those windings, which means the windings inevitably will heat up more. Is that correct?
That is exactly correct. Class B is what we call general purpose. As a general rule, I don't use Class B motors on VFDs, period. Now, there are some applications you can get by with it if it's a general purpose and it's going like a 2-to-1 speed range. And the motor is very, very close to the VFD, within like 50 feet of conduit. But on multi-motor applications, on condensers, on HVAC, you should never use a motor on a VFD with Class B Bravo insulation, in my opinion, because the motor's just not going to last. It just can't take that kind of abuse.
Right on. And then, and then lastly, we have Bacnet, which just about everything is going to Bacnet right now. So, like Walmart made this big push a couple years ago. They wanted everything Bacnet. Bacnet is what they call engineers protocol. Like, it's a big building protocol for like HVAC stuff. Just about everything can be Bacnet. It is a basically group of points you could read and write to. A lot like Modbus. It's an RS-485 protocol, so it is COM voltages. It's why you see like everything in Walmart now is Bacnet. Whether it's Novar, whether it's Sporlan talking to Novar, that's all Bacnet. So what they're doing with that is CPC can even do Bacnet. I mean, they have tons of Bacnet stuff. Your Linux rooftop stuff, carrier rooftop stuff. Everything's about integration now. They're trying to push all these control systems to integrate to each other. And I mean, they're trying to make it so everything can talk to each other. So they could take this case lineup and make it SC3s, this case lineup and make it Dixel stuff, this case lineup over here with this controller. They want everything to be open protocols, which is where all these control systems are fighting each other right now, because none of them wanted to be open protocols because they all want to sell their boards and their hardware. Well, now they're not. They're just selling the front end. So that's why you see this big push to Bacnet, because it's a group of points and they have to follow a standard so everybody could read and write to these points that does Bacnet controls.
Not just that, but they want, we're used to, like Bullseye stores, they have ALC, for, their communication for their HVAC, and, what I've seen usually, Emerson for their refrigeration. And now, everyone's trying to get, why should I have two different systems? Why am I paying for two different systems? Everything should be, basically integrated with each other. You know what I mean? That's what, that's why they're trying to do that. That's why you can have, like you stated before about the, Bacnet being controlled through E2 for the Linux stuff or the carrier stuff.
Yeah, everything's going to open protocols. I mean, we're light years behind the HVAC side. I mean, they're to the point where you could have a Linux you could have a Linux rooftop on a train control system that's controlled by or accessed by Metasys. I mean, they're light years ahead of us on graphics and stuff. I mean, most of our stuff is done as cheaply as possible on our end, so we get the crappy graphics and the brick controllers. So, but I mean that's a customer driven thing. But that's going to be changing soon. I think it's just everybody's being pushed to integrate. So
So in all these different protocols, everyone has their own little niche, right? Echelon, I don't believe there's not different baud rates on Echelon, correct?
I don't think so.
But like on back, okay, but on Bacnet, Modbus, IONet, everything basically has its own baud rate. What baud rate is basically the speed at which it's communicating. So if you have one controller communicating at 9600 where it's talking normal, and then you have another one controlling at 115.2 kbaud, and it's talking like the micro machine guy, so you can understand it. So the two systems can't basically understand, and basically drops information, drops segments of important information going back and forth, and that's why you have to make sure all the controllers, as well as the main system that you're working on, is all set for that loop for for the same baud rate. And there is stuff that can't communicate on certain baud rate, right? Any Dixel product, you can change the baud rate on those. Usually they should typically be set up for about 115.2 because they're transmitting so much data back and forth, the percentage of the valve, all the superheat settings, where the valve is, and all that other stuff. Where the IONet boards, aren't really passing a bunch of information. So, putting that 9600 isn't a real big deal. But then, you might have case controllers that are on Modbus, and then maybe you have the core sense modules that you have, communicated to, the E2. And basically, if, you might not be able to put those on the same COM port because, if the case controllers are speaking 115, maybe those core sense modules have to be at 9600, and you basically can't have those two intertwined because they're talking at a different speed.
So with some of that stuff, I generally try to run everything in 19.2. Even like the Dixel stuff, I find those case controllers work better at 19.2. Emerson says 9600 sometimes, and then some stores you see them at 19.2. I run my stores at 19.2, and then same thing with all the Copeland stuff. It seems to mesh up a lot better. Like I've never had problems running at 19.2 until you get to CoreLink.
I think there's a bunch of people that have issues with CoreLink. Yeah, like even RDM, which can integrate with just about anything. There's only certain ways that you can communicate with it, and yeah. Although, be it the fact that RDM is like basically like a web based controller, a lot of the CoreLink controllers have their own HTTP address, so you can put it in there and basically bring it up on the RDM. I've done that before, plugged in the computer to it.
So RDM is the closest we get to a building controller. I mean, RDM is probably the most open protocol controller there is. I'm pretty sure it could do everything. I mean, those guys have told me they can make it talk to CPC boards that they want.
Mm-hmm.
I don't think Emerson would allow that or like that, but they can do it. I'm pretty sure they could do just about everything. They could probably even do Danfoss if they wanted to.
Well, the one store I saw them talking to, I believe an ALC board, and then another store I saw them talking to the same store. They were talking to a CoreLink, and then that they had it talking to their RDM controllers, and they had probably like 5 or 6 different controllers that they were actually talking to, and I believe they can actually also communicate to the Linux stuff. Is that
I literally think they can do anything. Like they that controller has every single communication protocol in it.
Wow.
Like even Ethernet, like it literally has every single communication protocol in that controller.
And CPC has the it may not necessarily be in the options, but there is a list of licenses that you can buy. When you have a controller coming out the gate, an RX 400, it has the capability to talk to an S3C, but you have to buy the license for that. They also, if they, from my understanding, if they have a customer that has a special need, that's something they wanted integrated, they have guys out there that will actually, learn the protocol that is communicating with and kind of, mesh it in with the E2 and actually build a license for it. So they're able to do that.
Allegedly.
I've seen it.
It's very, very rough in the beginning.
I'm not saying it's not rough. I'm just saying it's feasible.
Yeah, it's let me tell you this. Emerson is damn proud of their licenses too.
Yeah.
They really get you with those ones. those add up quick. But no, like Brett said, you can get licenses for just about anything. So that's why all these communication protocols are coming in. Same with RDM. They're newer to the US. You're going to start seeing them a lot more, I think. They're all over Texas now. Up here, I think Fresh Time's the only one that uses RDM.
And they have some smaller like convenience store stuff that they were telling us when we went to training for it. But yeah, like you said, like everything HVAC base is, they use what are called Jace controllers, which is a controller that can talk to just about anything. Because like you said, it's in the way open protocol that it can communicate. Back to communication stuff, just making sure that you guys are aware. I touched on the termination resistors lightly, but you have to go by the wiring standard per the manufacturer. Per the best wiring practices. I know Microthermal has their best wiring practices. Where it actually breaks down what wire you need, what the resistance should be, and so on and so forth. Also, CPC does have one as well. I believe there's one for Danfoss, but I haven't looked at it for a minute because I haven't worked on a Danfoss controller in a minute. But you have to make sure that the terminating resistor is the exact one. They're on ALC. They on their older boards they would use a regular 120 ohm precision resistor, and now with their newer boards, there's usually a four port prong plug. It looks like it's the same plug that they use on the back of the MPAS variable speed evaporator fan motors. That's what it looks like. But basically, there's a plug-in resistor. The only bear about that is if the controller has lost power because it's a power-based chip. It actually looks like they refer to it as a SpongeBob because that's exactly what it looks like. It's basically a small rectangle board that has orange shrink wrap on it, and it literally looks like SpongeBob SquarePants. But if that board is not lit off, you lost an evaporator fan motor or the unit lost power. That one board not having the terminating resistor on that loop could potentially cause the whole loop to go down or the whole loop to have intermittent communication issues. And like on something like CPC, anything on the IONet, usually you have the terminating jumpers on there that tells you, how to terminate it, how to not terminate it. Anything that's Modbus for CPC uses also a precision resistor as well. And there's different nuances to everything. With the Modbus stuff, usually like the IONet stuff, if black is your positive, red is your negative, and then shield is the shield part, right? The silver. You go like for like, right? On Modbus stuff, typically they have you actually reverse. They basically invert the wires. So if the positive was black, then basically your negative on your case controllers are going to be black.
So just about any time with Emerson just about, not every single time, but anytime you're doing a third-party controller, whether it be a Nidec drive, Danfoss drive, any kind of third-party Dixel, KE2, that stuff, you're going to want to invert the comm loop. So you want to invert it at the controller. Do not do it at the cases.
Why?
Because that becomes confusing.
To who?
So to somebody who has to come back and troubleshoot it later. So you're going to want to invert the comm. Novar is the same way with a lot of stuff. Novar, some certain boards like black label and white label min IOs. I think the black label min IOs have to have the comm line inverted if you're on legacy Novar. If you were a white label min IO, it would be the same as the Spectrum boards. So that's why certain boards that you got to really pay attention. Certain boards you may need to invert the comm line on, and it'll tell you, in there what happens. All Modbus Dixel stuff with an E2, you have to invert the comm line. All Nidec drives, same way. So black would be positive, or if you're at Walmart, white and black white is positive, black is negative. You're going to invert it still. So that's one thing to really look out for is when you're inverting the comm. And then second thing I want to talk about is transformer voltages. Huge missed problem. So make sure transformers are tapped properly. If you have a 208 rack, it's probably got to come out tap 240. So if you got 205 volts, 200 volts, and you're tapped for 240, you may only be getting 18 volts at the transformer, 17 volts. Well, that may intermittently drop down when it's 100 degrees in Chicago or Texas, and everybody's running their air conditioning and the power grid really sucks and they're getting real low voltages. Well, now it's going to be a real big problem because say it gets down to 198. Well, now you're dropping to 15, 16 volts. And now you got comm boards dropping out randomly. Time you get there, it's cooled off a little bit. And next thing you know, the voltage is back up and your voltage, you got 21, 22 volts. You think it's fine. So that's another big thing to check. I always check, make sure my transformers are tapped properly. And then let's talk about center tap transformers. So some boards require center tap transformers. A center tap transformer is basically where they tap the middle windings. And then they're getting 12 volts out of it. So from the hot to the center tap, you get 12 volts. From the common to the center tap, you get 12 volts. And across the transformer, you get 24. So like Emerson, all boards that do one function need to be tapped. It's the easiest way to remember this. So any board that performs one function, whether it's an output board, an input board, an ESR board, those boards all do one thing. They need to be center tapped. If a board does multiple things, like a multiplex board, it does not need to be center tapped. That is the easiest way to remember that.
Also make sure that, even though the schedule or whatever says that, it's supposed to be, an X, a 240 volt transformer or whatever, just verify that. I've had a couple of new racks come out of a certain manufacturer where, they said they were supposed to be a dual tap, 208, 240, and they weren't. They were basically only 240. So same instance that Kevin was just talking about, it would run fine all day long, and around anywhere from 2 to 4 o'clock, the highest part of the day, basically voltage would drop down. We get the call again. Guy would go later that night where it would cool off, no problem. Then we get the call again the next day because it was just an intermittent voltage issue. And that transformer thing is a really good thing to remember, especially even doing with rooftop units. I know we're dealing with comm, but just to put it out there, when you guys are dealing with, HVAC issues, one of the first things you check is the transformer tapping, because those things are slammed in there really fast, not really done an efficient startup. Always check transformers on anything just to make sure you don't have that issue, especially big cities, where you have a large draw on the grid. I remember being down in Philly and, the voltage would get down to 184. We had to end up putting phase loss monitors on a lot of the equipment, even single systems, because, the grid would go down voltage would drop down that low, and we ended up burning out 4 or 5 compressors on a facility, you know?
Yeah, it's how like every store is in like residential areas in Chicago, where especially the older parts of the city where they get like they're only getting 208 service, not 460. It's a disaster. Like you're lucky to get 196, 195 is pretty good in the middle of summer. They eat condenser fan motors for breakfast.
It's awesome. The VFD, dig that.
Oh, they love it. Love it. So that's one big thing is transformer tapping, and if we're looking at comm stuff. And then for the love of God, if you're running a comm line or you're doing anything, label the damn wires to and from. That has got to be my biggest pet peeve with electricians is them not labeling wires to where it goes and where it's from.
It wasn't on the spec.
I do that. Oh, the suggestion sheet. It's the suggestion sheet. Oh, say that twice. So I when I do my stuff, I am a Nazi about this. I want everything heat shrinked, all the comm line inch heat shrinked, but I buy the perma sleeve wraps on the label maker roll. They're expensive, but they're worth it because you don't got to do 2 things at once. But and I label where it came from and where it's going. So that way, the in and the out. That way I know where all the wires go because it'll make it so much easier to troubleshoot, especially when you're splitting the network in half and you're going apart. And like when I have comm issues and we're talking about splitting the network and you start at the beginning and you get a couple boards on you know that the E2 is not the problem or the controller is not the problem. You go to the first 2 boards. I split it off from there. I plug the first 2 boards in. If I get it on or the first board, I get that one online. Then I just keep going. So then I may jump 5 boards, and bite off a bunch. And if I unplug the rest of the network and get those 5 boards on, okay, then I keep going on. I just keep moving on down the line. But if I don't know where to go on the line, we got a huge problem. I'm going to be spending a bunch of time trying to figure out where this comm loop is going and tracing it out. And that's why labeling your wires and actually following the print is a great thing. But also, I don't know who writes some of these prints because they're terrible.
So I'm sitting here thinking while you're talking, and you're expecting someone that can't use a broom to label wires and follow a print.
And or pick up their material or mess or.
Well, yeah, that's what I'm saying.
I followed a room a couple of weeks ago, and I was very concerned.
Really?
Oh yeah. I mean, I figured something bad was about to happen. If you guys don't know, electricians are probably the laziest, or the not laziest, the worst at cleaning up their mess ever.
All right. Well, hey, we're going to cut it off there. We'll have more information. We'll get deeper into, different manufacturers and get you some concrete voltages and stuff in the next podcast we do. Guys, thanks a lot for listening again, and catch you next time.
Yep. Have a nice night, guys.